之器。
Okay, good morning, everyone, and thanks for joining this webinar on Kubernetes and NSX. So I'm going to have a focus today on application modernization and how we can help with the networking and security for modern apps. But before I start with that, I'd just like to share that we actually have a lucky draw running today. The lucky draw will be for those people who attend the first 15 minutes of this session. We'll be doing it at the end, and we actually have a set of AirPods too. So thanks very much for attending, and please stay till the end and you have the chance to win the lucky draw. Also, the feedback form is very important. I'd like to hear your feedback and see what you think about the content, think about the session and the presentation. So there is a link in this slide. I'll give you a few seconds to click that, maybe open it up for later, or maybe scan the QR code and you can open the link on your phone as well. So I'll start with the agenda. So going over what we will speak about today. First of all, I guess many of us may not be that familiar with VMware NSX. So NSX is our network and security virtualization platform. So first I'll give a brief overview about NSX itself, and then actually touch on the challenges that we're trying to address. I mean, no point presenting a solution unless we go through the challenges. So I'll touch on the challenges, then kind of give you an overview of the few main use cases that we try to address with container networking. After that, we'll deep dive a bit more into the actual solutions. So when we dive into the solutions, I'll go into each of the use cases in technical detail. And hopefully this will help you to really understand how we're addressing those challenges at the start. After that, of course, I'll have the closing thoughts and we'll do the lucky draw and feedback. So when I go to customers today, they have three main challenges when they're trying to modernize their applications. And when I say modernize their apps, I mean things like if you're, say, a bank and you're trying to reach out to your customers with new features, you know, get ahead over your competitors. Speed is very important, right? So when we try and add features to grab more customers, make them happy using the applications, then speed is very important. And most customers I talk to, this is a challenge for them. Usually projects are a bit delayed. They're rushed to go to market with new features for their online applications. Of course, savings is a big concern for all of our customers. You know, you want to save cost, both during buying new technology, but also for operations. The third one is security. So security is a huge one for all of us. And we want to make sure that whatever applications that we deploy, they are secure, they're compliant, and this is a really #1 concern and actually a big area of spend for all of our customers. That's what I see today. And really, VMware NSX is a huge enabler for these three areas. So all of these three areas, NSX can really help businesses out, and that's what we're really focused on from a high level when doing networking and security for modern applications. So I'll just touch on the speed to start with. So as I mentioned, every single customer that I go to, speed is a huge concern. I'm sure it is for you as well. If you have a couple of projects going for a new app, I would say there's a big chance that all of us get a bit delayed on that. So we want to speed up the delivery of those applications, speed up the time to market. So touching on that, if we consider for a moment the public cloud, this is the type of experience when it comes to networking and security that a lot of our customers and you guys would like to experience, right? Meaning that instead of, say, putting in an order, waiting for some routers, switches, firewalls, racking and stacking them, hooking up the cables, and then deploying policy of all manual configuration. After that, actually testing it out, figuring out things are wrong, and then redoing it. This is the traditional experience that I'm actually used to, and I see in all of our customers that haven't modernized their networking and security. But what you really want is just to have a few clicks, and then before you know it, your networking and security is up. And that's how that's the experience that you have in public cloud. So in Amazon, you can just with a few clicks have your networking and security, your connectivity up and running. And I mean, that's a big difference compared to, say, with doing it in the traditional way. And essentially, with VMware NSX, that public cloud experience is the one that we want to give you on-prem. So that same thing where basically you can bring up networks with a few clicks, they're automated, you can deploy a policy in code. That's the exact way, that's the exact experience that we want to give you in your private data centers as well. So we see that networking should just be code, meaning that instead of having a bunch of physical appliances and all the networking and security inside there, we've abstracted that. So in terms of things like switching, routing, other things I'll speak about, all of those functions, we're actually abstracting away, we're virtualizing, putting it into software code, just like we did with compute and vSphere. In the same way, we're doing it with networking. We're taking the network intelligence, putting it into code. And then the second thing is that we still need those routers, switches, those physical devices, but we're using them as an underlay, meaning that we pass all our traffic on top. We have all our intelligence sitting on top in software, but we're using the physical routers, switches, cables, we're using them to move all our bits as a reliable underlay for all of our traffic. So in essence, that's what VMware NSX is, and that's how we're seeing networking today. And it is a really complete solution, meaning that it's not like we're just doing firewalling, for example. We're doing routing, switching, firewalling, load balancing, and even things like IPS, IDS, with collaboration with other security vendors, which is our technology partners. So it really is a complete security solution that faithfully reproduces many of the traditional networking appliances that sit in your DC. So we cover all the normal use cases that you would need in your whole data center. The other thing is that we're not only abstracting those network functions and putting it in software inside your DC. We're able to do that for other places, such as telco networks, such as public cloud. And as we're talking about today, for not only VMs, but also bare metal containers, and yeah, I mean, microservices. So there's modern applications. So we're allowing you to virtualize a network and have the same type of capabilities across VMs, containers, on-prem, and also in public cloud. So the platform itself, still on that NSX topic, the NSX platform itself can do a number of things. I mentioned things like networking and security, but also automation. So when we have dynamic workloads, such as containers, those manual methods of, say, configuring a VLAN, configuring a firewall policy manually, these things really don't make sense. Because if you've got hundreds of workloads coming up and down every day, which are microservices, it really doesn't make sense. It's not practical to do networking and security manually. So automation is a huge part of this. The other one is visibility. So although you may have like a pod of microservices somewhere and they're connecting to VMs somewhere else, but it's so important to have visibility all the way, and that's what we can help with. Another interesting point is that we're actually allowing multiple hypervisors. So don't think that actually NSX is just for vSphere workloads. We can also enable it on KVM. As I touched on before, we can even do containers, bare metal as well, and multiple public clouds. So that's the NSX platform in a nutshell. So moving forward, I'd like to touch on the type of challenges that customers typically have with networking and security, specifically when it comes to containers. So I won't really have a huge focus on NSX. I'll kind of change gears and really like zoom in on the container challenges to start with. So if we look at a survey of the whole industry, and these results kind of don't really change so much over time, but these are main challenges that are pulled from customers across the whole IT industry. And complexity is obviously a big one. So is monitoring, networking, and security. And actually, those areas that are highlighted in orange, they're the ones that we're trying to address with NSX. And they're really like the major ones that most customers are suffering from. So if you are looking at that containerized workloads, these are the type of challenges you may be facing. That's our focus with NSX. I'm going to start going a little bit more technical now. So basically, we'll start with the technical challenges with the traditional container networking. So on the left-hand side of the screen here, you might have a container platform, a platform as a service. And if we look at the top of the screen there, we see a container network and we see a virtual machine. And typically what happens is, say you need to connect your traditional VM workloads to your container network. The only way that I see customers typically doing this is through NAT. So everything is just NATed out. And you typically have just a pod of containers sitting in a corner somewhere. Everything is NATed out. There's no normal connectivity to the rest of the network. The other one is firewalling. So for firewalling, if you're NATing everything out, it's actually very hard to do segmentation. And since security is a huge concern today, I mean, without microsegmentation, this becomes a huge challenge. You just have a pod of services, could be hundreds of small services with essentially full access to each other. So that's another challenge. So the other one is operational tools. Typically for microservices, the type of tools that are there are completely different from the ones that are used for the traditional network. So this also poses a challenge. It's a silo. The other one is that, say you have a couple of different platform as a service and you have different tenants leveraging those different platforms. So if you have different tenants leveraging those different platforms, you need some way to do multi-tenancy. So multi-tenancy is really a huge one for all of us trying to do microservices. You may have 3 or 4 or 5 lines of businesses which require multi-tenancy. And the networking, if you're doing the traditional hardware networking, then actually there's very little ways that you can match the multi-tenancy on the network to the multi-tenancy you require for your actual applications. So now let's look at the way we approach it on high level. So what do we do? NSX approach to container as a service or platform as a service. So in terms of the connectivity, instead of having to NAT everything out, we actually bring layer 3 down to our container networks. Microsegmentation, we can also do microsegmentation down to our container networks. The other thing is that all those operational tools that we've been used to for many years, we can apply them to our container workloads as well. And we are able to effectively give you multi-tenancy from the network side for your actual lines of business, or basically matching your application multi-tenancy. So now touching a little bit more on the specific challenges with networking and security with Kubernetes. So typically we have to address with Kubernetes a couple of things. It's essentially layer 2, layer 3, and firewalling, also load balancing. And these are kind of the very common open source projects that allow us to do those. These are nothing to do with VMware, but actually they're kind of pretty common in the industry platforms to handle layer 2, layer 3, and load balancing. So the challenges with them is that these platforms like Flannel, Calico, Nginx, they'll be focused on your container pods only. So they won't have any integration with your actual VM workloads. The other thing is that the constructs, the type of networking terminology and constructs they're using, it doesn't map to your traditional enterprise network. And the really big problem is, on top of that, is that if you're trying to operate these environments, then you need a way to see the whole environment, meaning that your container, your VM, your bare metal. This is not possible if you're using multiple different open source projects for your container workloads. If you're doing that, then what will happen is you have another silo. So not only do you have like your silos that already exist, like your network team, your security team, your storage team, you'll also have another silo who is managing just the container workloads, and it's unlikely that they'll be able to to operate the whole environment. So how do we actually address that with NSX? So, I mean, if we look at layer 2, I mentioned before, a popular project is Flannel, but we can handle this with NSX. For layer 3, a popular project is Calico, which you can layer or sit next to Flannel. We also do this with our platform. You are able to do some IP tables type of firewalling as well, with a couple of great open source projects out there as well. We also handle that. And if you're doing layer 7, things like sidecar proxies with Istio, maybe Envoy. So we are also doing that. We have NSX Service Mesh in private beta at the moment. So we're also developing a platform related to that. In terms of load balancing, so load balancing, HA proxy or Nginx, I mean, we have built-in load balancing as well. And just to wrap it up on that point, we have end-to-end visibility and troubleshooting tools that cover the whole lot. So on the right-hand side, you have the open source way, which is a bunch of different projects which are kind of patched together. And you need specialists for all of these. So a specialist that's taking care of maybe Nginx may not be so experienced with Flannel or Calico. So you need like specialist little silos in the teams that operate these environments. But what like large, medium or large enterprises, governments, and financial customers, basically most of us out there want is actually a single platform that gives you all of those features and gives you an easy way to operate the whole thing. Then that's what we have with NSX. So instead of having multiple different, say, open source projects or different type of solutions, we just give you one platform that actually covers the entire lot. So now I'll zoom in a little bit on the use cases. So what are the use cases that we can satisfy with NSX and Kubernetes? To start with, I'll just go through a bit of explanation here. So traditionally, as I touched on earlier, but in a bit more detail now, is that traditionally for container workloads, everything is port mapping, it's natted out. But then the challenge is like, if you have a particular service, say, you know, any type of service, and you map that to a particular port, and then you have hundreds of these, how are you ever going to track these services? Especially if they're coming up and down, changing. This is not practical at all in a corporate environment. So port mapping is definitely challenging. And in production, in enterprise environment, this is just not practical and it's not done. So then we go to the next stage of the evolution, which is CNI, or Container Network Interface. So essentially what we have is that your containers have an interface that is visible to the network. That way you kind of like you can apply, say, an IP address to a particular workload, even if it's containerized. And that's what we're doing with NSX. The next stage of the evolution would be Service Mesh. So as I mentioned, we actually have NSX Service Mesh in private beta. And this is abstracting all of the networking and security into something like you could call it a sidecar. So you have your pods of containers, and then you have a sidecar, and all of their networking goes through this sidecar. This sidecar forms a mesh with others and provides you end-to-end networking, security, and load balancing, all this kind of stuff. So every container we see as really a first-class citizen of the data center network, meaning that we're giving the containers the same type of capabilities, like your switching, routing, NAT, load balancing, all of that stuff that you're used to with your VM workloads, we're providing for your containers as well. There's not really much differentiation. We're not saying, you have container networks, we have like a different system for you. It's not like that. So with that same NSX data center network, we can give you connectivity and all the networking and security that you're used to with your VMs. That's a really great thing. So the next one is in terms of the first use case actually is for actually connectivity. So essentially what we do, as I mentioned just in the slide before, that actually we treat containers roughly in the same way as the rest of your VM workloads. So you can have your data center network with BGP, NAT, or layer 3, whatever you prefer, connected to multiple container platforms. You could have your straight up Kubernetes, you could have Pivotal or Red Hat OpenShift or whatever it is, but you can also, into that same network, hook in even bare metal workloads or virtual machines. So this gives you huge flexibility to put together different type of topologies, layer 2, layer 3, and hook them into your containers or VMs. The other benefit of this is day 2 operations. So it means that the same team that is taking care of the data center network will take care of networking for both the containers and both the rest of the workloads, your normal VMs, because it's the exact same platform. You don't need to create another silo for your microservices. The other one is segmentation, so firewalling. I'm not sure if we're all familiar with microsegmentation, but essentially what it is that you can firewall in a very granular manner, meaning that every single NIC on every single VM or container workload, you can apply the firewall there. So you no longer have to do like firewalling per subnet or firewalling per IP address. It's actually per virtual port. And so we're actually able to give this capability not only to VMs, but also to the microservices. And just as a side note, this is a full stateful firewall. So it's not something like IP tables. It's nothing like that. It's a stateful firewall, and we actually apply it from the kernel level. So there's no agent here. It's not in the guest OS. It's actually kernel level stateful firewalling. This way, of course, you decrease your risk massively, and in terms of compliance for your container workloads, you can comply just as you do with your VMs to your container workloads as well. Another one is load balancing. So with load balancing, what we're able to give you is that if you're familiar with Ingress or service type load balancer in Kubernetes, essentially we have a built-in NSX load balancer that you can use for that. So for all of your containerized workloads, you can use the NSX load balancer. It's built in and software defined. And last but not least is the end-to-end visibility. As I mentioned, it's great having like all of these cool technologies, connectivity, but it's no good if us as operators cannot get visibility across the whole thing. So actually, because you have one platform across the whole lot, we give you features that give you the visibility across everything. So in terms of your layer 2 networking, you can see all the stats. You can actually see all the traffic. You can do like a trace flow. You can copy traffic and send it somewhere else. Of course, with load balancing, we give you statistics and health on top of the load balancing. In terms of the firewall, it's the same thing. So statistics on the rules, we give you proper firewalling logging and for your audit as well. In terms of the platform, the whole platform itself, it's all the normal type of stuff. Like you have CLI, you have GUI, you're able to get syslog from every single component. You're able to integrate with AAA and two-factor authentication. In terms of logging, we have really good integration with Splunk. We have built-in logging with Log Insight. And in terms of visibility, we don't have time to go in detail today, but we have an awesome platform called Network Insight. So vRealize Network Insight. So this platform gives you visibility all the way from VM into containers, onto physical, and even into public cloud. So we're able to give you a great visibility across the whole thing. At this point, I'll probably just stop for a moment to do a bit of a poll. So I'm just going to bring up the poll, one sec. So I've just launched a poll. I'm hoping that some of you can see it up there. And if you don't mind just taking a minute to answer those 4 very short questions. And I'd just like to see some of the results and hopefully share them back with you. Okay, so I think you'll be able to see the poll now. So just hopefully take a look on your screen. I hope you can see the poll, and just take a moment to answer those questions. Okay, I can see some results coming in. I'll wait about 30 seconds or a minute and wait for those to come in. Yeah, so I'll give it another 30 seconds or so, and then I'll share the results with you guys. Okay, so thanks a lot for answering the polls. I'll just end it and share the results. So I'll discuss them with you. So the first question, which is what type of workloads are we all running today in production? And 80% of us are running VMware VMs, and that's not a surprise. If we look at other type of virtual machines, it could be from Microsoft or whatever it is, it's only 6%. And with containers, it's about 6%. So I can imagine that there's a lot of interest in container workloads. But today in production, yeah, I mean, only 7% of us on this webinar are actually running containers in production. But yeah, no surprise, VMware VMs is 80%, and all of us are running bare metal as well. So in terms of NSX, actually 33% of us are experienced on NSX, which is a really great number. No is 69%. So that's fair enough, that's great, and that's why I did the introduction for NSX to start with. With Kubernetes, 17% do have some hands-on experience with Kubernetes, which is really great because it will make the next slides a little bit more meaningful. 85% said no, like no experience with Kubernetes. And once again, that's very understandable. And this session and the rest of the slides are pretty like entry level. So it's not going to be like super advanced stuff. I hope it'll be understandable for everyone. And if we talk about if you want to, the last question, which is, do you want to run your workloads on-premise or public cloud? 75% are actually focused on on-premise, and only 25% are looking on public cloud. So that's very meaningful for me and this session as well, because we are focused a little bit here on an on-prem solution, which is like 75% of you. But in fact, we do have the same kind of capabilities on public cloud. So that's also cool. So I'll move on with this. I'll just close it off. Is the poll gone? Okay. Okay, great. So let's go into solution details. So I talked about the use cases in the last few slides, meaning the networking, which is connectivity, then the firewalling, then the load balancing and visibility. That's what I talked about. But now we're actually going to zoom in detail on each of these things. So when we think about NSX, what were our key design goals? First of all, we don't want to stand in the way of our developers. We don't want to give them different or difficult ways of doing things. That's a main design concern that we had. The other one is to really map the existing Kubernetes constructs to the way we do normal networking in the enterprise. Third of all is to give the same security platform across containers, VMs, bare metal, and of course visibility, which I've touched on before. And how do we actually do this? So we've got, this slide is a lot going on there, but let me try and simplify it for you. So NSX Manager, which is in the middle, that's just our GUI, our management plane, where we actually do all our configuration, either through GUI or API. On the left-hand side, we have, say, different type of platforms, such as, say, the Pivotal Container Service, which is PCS, PAS, or even Red Hat OpenShift, or even like straight up Kubernetes. So you can have all of those. In this example, you can have all of those in your environment. Then you have NCP, which is something that we create, an NSX container plugin. This runs as a pod in your environment. All it does, just to keep it very simple, is it's like a translator. It's like a language translator between the different container platforms and our NSX Manager. So what it does is that it listens for changes in Kubernetes, and it translates those and configures them in NSX Manager. Then on top of that, we have something that is called the CNI, so Container Network Interface. So CNI is something that runs in every single container host. So what happens is that after that configuration from, say, PKS or Kubernetes is translated into NSX Manager, then after that, that configuration is done on the host, on the relevant host. And that's done by something called the CNI plugin. So it's really only two components here which are new, which is NCP, which does the translation, and CNI, which does the configuration on each container host. And that's essentially how our solution works. So let's deep dive a little bit into networking now. And I hope this is not too networking heavy. I'll try and keep it simple as possible. So the straight up, the most probably common model to hook up our containers into our enterprise network is like this. Let's start from the top. So in the top right, we have our physical network. That's the gray pieces. Under that, we have this green router. That green router is actually an NSX router. Below that, we have some containers running on our K8S nodes, on our container nodes, right? So say we log into our master and do some configuration. We create a namespace. What we do is create another, like a tenant router in there. And then basically it's hooked into a layer 2 network, which is the purple line. So that purple line is a layer 2 network. And yeah, I mean, it's assigned to a particular namespace. It's got some IP address range assigned to it. And even that IP address range is assigned from NSX. So within NSX, we have pre-configured those IP ranges. So when you go and create, say, a new namespace, what happens is that layer 2 network is created into and hooked into that namespace. It's given a IP address range. So we take care of the IPAM for that. And then, you know, your container workloads are hooked into that. So our namespace on the left, foo, our namespace on the right, bar. These are two different tenants, and with one namespace each. They've both been assigned routing and basically a layer 2 network, and they're able to talk to each other through our NSX network. And all the firewalls inside, all the workloads inside are actually firewalled with our distributed firewall. So each of those pods inside there at the bottom are actually hooked into a particular port. So that port is what we firewall on. So that's our main type of solution that we have today. The other thing is that the actual SNAT that we do is typically done on the provider router, so that green router. That green router has a SNAT, which then is visible out to the physical network. So from your physical firewalls, you're actually able to use that SNAT address to do your security policy on the physical way. But our distributed firewall, our microsegmentation, that is done on every container pod, which is down the bottom. That's how we achieve the microsegmentation. The second one that I'll explain is actually a little bit different, because some customers may have a huge Kubernetes cluster, and actually the tenant is, they have multiple namespaces in there. And so instead of doing the SNAT on the provider router, they're doing it on the T1, which is our tenant router. So that way we're able to have active-active connectivity up to the upstream world. So that's the only difference there. So touching on security. Security is a very interesting one with the containers. And there's a couple of ways we can do it. So first of all is that we can have a network admin or security admin with not much to do with the container developers. They predefine the rules. So within our NSX firewall, we have a network admin predefined rules, and then the developers use tags on their containerized workloads. Those tags are matched to our rules in the distributed firewall. So essentially, it's defined by network admins, but it's consumed by developers. So the developers aren't really like defining any of the rules there. The second one is for developers to actually create some of the rules. So what happens is that in Kubernetes, you have network policy. Inside network policy, the developers can actually put some rules there. So once container workloads are defined, then those rules are populated in NSX. And I'll dive into this a little bit more in the next couple of slides. The last one is a hybrid mode where the network admins will actually define some of the rules in the rule set, but developers can also go in and do network policy. So it's a hybrid way. The way it really works and the way it looks is that the metadata from your Kubernetes YAML file is actually all visible from NSX Manager. So on the right-hand side, that's actually NSX Manager. We can see the metadata inside NSX Manager. And what we use that for is to match workloads into groups. So say, for example, we create a new group, right? So a group in NSX, we can actually match various different things. So what we do is that we create a group. Our group is called, say, NSX demo pods. And how do we define the membership? The membership is based on tags. So we'll say that, well, in this case, for our NSX demo pod group, let's match tag NSX demo and scope equals app. So any containers that the developers created with those tags will jump into that group. That way you see that actually, if you look at the members of this group from NSX side, it's going to show up the matching pods based on those membership criteria. And then the really cool thing is that in your firewall, which has your source and destination, you can use this group as a source or destination. So essentially, you create a group which you can use as a source or destination in the firewall. The group has members based on a certain criteria, and that criteria is actually from tags in Kubernetes. That's the way it all fits together. The other one is Kubernetes network policy. So other than doing the predefined way of groups that match tags from your YAML files, instead of that, you can actually have developers create network policy, and that network policy, it translates to firewall rules inside the distributed firewall. So you might, just to dwell on that for a second, you might have a question in mind, a common question that comes up. Say you want to maintain some type of control from the network admin side, but you still would like the developers to be able to define their own policy. This is made possible because at the top and bottom of the firewall rule set, we actually have admin policy, which cannot be touched by the developer side. So that way you have your overall policy on the top and bottom of firewall rule set, but you're still allowing developers to create their rules in the middle of the rule set. So that's the hybrid mode and how we're able to demark the responsibilities of network and developer. So the other one is, the next use case is load balancing. And essentially what we do here is that we're able to do both ingress. So ingress is like typically through HTTP or HTTPS. And our NSX load balancer, our software-defined load balancer, actually works as an ingress controller. Otherwise, of course, we can do the layer 4 load balancing. So your normal TCP or UDP load balancing. And yeah, I mean, we support both. It leverages our NSX load balancer, and you know, you can support various different platforms like straight up Kubernetes or Pivotal or, you know, Red Hat OpenShift. A couple of features which I won't go into in too much detail, but we do things most importantly like TLS termination, so SSL termination, and we can do URL rewrite. So say depending on what web address somebody goes to, they may go to a different service. We do X-forwarded, so all of these type of features that you're used to from a normal physical firewall, physical load balancer, we're able to provide that as your ingress control. The other thing is checking the stats. So this is probably an important one for most of us. A normal ingress controller or traditional ingress controller would be physical. So it will be maybe a physical F5 or maybe a NetScaler or something like this doing the ingress control. From an ops perspective, this means that you would need another team to troubleshoot any type of issue or to have any type of visibility. You'll have the load balancer team doing that. It's not really the case with NSX, because like I mentioned, we do all the networking and load balancing from NSX, one platform. From that same platform, you're actually able to see the health of your virtual servers, the health of your pool members. In terms of statistics, we give you stats for your containerized or VM workloads straight from NSX Manager. So all of this stuff is available to the team that's taking care of the data center network, meaning that we break down one more silo. We don't have that specialist team which is still required, but we don't have those guys needing to take care of the containerized workloads. We make things a bit easier for operations. So now on operations, we also have an option for Concourse Pipeline. So that way that, say you want to deploy your NSX Manager, you can just go onto GitHub, take a look at the link which is shared on this slide and will be shared later. And you can actually install NSX, do some configuration, and even create all the logical networking straight from your Concourse pipeline. And after this, in terms of your Kubernetes install or your PKS install, whatever it is, you can launch your next pipeline for that. So that way your whole deployment and configuration is automated. So I'll stop there for another poll. I'll just get. Okay, so this is another 4-question poll, and pretty straightforward questions as well. So just based on the last couple of slides that I went through. So if you can see the poll, please take a look and take a moment to fill out those questions. Okay, thank you very much for your poll results. And so only about a third of us have voted this time. Last time, a lot of us voted, but I'll end the poll now and share the results if you want to take a look. And I'll talk through it as well. Are we able to, you can see the results now, right? Okay. So microsegmentation, where does it happen with NSX? Actually, it does happen in the kernel. So it's the guest OS has nothing to do with microsegmentation. It doesn't know that it's happening. We actually do it in the ESX kernel itself. So it's completely different from doing it with some of the other open source projects out there that essentially leverage IP tables. It's not really like that. We actually abstract that into the hypervisor itself. And with microservices and NSX, what can you run it on? Actually, you can run it on all of the platforms that were listed there. So vSphere, bare metal, KVM, PKS, Red Hat OpenShift. With OpenShift, we have a reference architecture as well. So all of this, we are quite agnostic to all of it. We're able to use NSX for all of these platforms. Kubernetes ingress, it is for our layer 7 load balancing. And I was just curious with the last question, because most customers I visit do have some challenges around visibility between virtual, physical, and containers. And yeah, I mean, 72% of us agreed that yes, we do have challenges there. So as I mentioned before, we have like a great, built into NSX, we got great platform for visibility, but we have another one called Network Insight, which is alongside NSX, which gives you that really awesome visibility across virtual and physical, which we don't have time to go into today. So thanks a lot for the poll results. I'll just move into the last few slides now. Okay. So putting it all together, let's just go through a summary about the NSXT and Kubernetes. So to start with, we have our physical data center network. And what do we have hooked into there is our NSX Edge router. So our NSX Edge actually hooks into our data center network. Then essentially what do? We say create a namespace from Kubernetes. And once that namespace is created, we hook in one of our NSX data center networks into that namespace, and we're able to actually do things like load balancing, firewalling, and even the network policy from Kubernetes, which is the firewall configuration itself. And just to highlight it again, we actually do the IP address management for the Kubernetes workloads as well, meaning that when you spin up a namespace, we give you the layer 2 network. We even take care of the IP addressing. And the integration we have, as touched on many times, consider this good for both VM, bare metal, even for OpenShift. For all of that we actually support. This is not a pure vSphere play. So moving forward with my closing thoughts, I think what we'd all like to aim for is not to have silos in our environment, not to have like a silo where you have networking and security just for containers, just for VM, or just for the cloud team. It shouldn't really be like that. What we'd really like is a common data center network that you can use for everything. And that's what we're providing with NSX. The other thing is that when we're doing container networking, we don't want to have alien concepts that are not well understood by the rest of our enterprise network team. I think it should be the same. And that's what we've done. So we've mapped those Kubernetes networking constructs into typical, well understood networking constructs from the enterprise networking. The other one is single pane of glass. So instead of having multiple different CLIs, multiple different APIs, multiple different ways to configure networking, firewalling, all of this, instead of that, we want to have a single pane of glass. So with the one platform, NSX, you're actually able to get could do configuration, get visibility across the whole lot. And of course, this makes troubleshooting and audit so much better, so much easier. And last but not probably most importantly is security. So we give you the flexibility to both have the network admins or the developers apply network security policy, so the firewalling. And this is a very different model to having a silo of container workloads and configuring some IP tables on the container host and then having security team configure like physical firewall. It's completely different to that. It's all in one place and it's done in a flexible manner. So in summary, that's how we're addressing the container networking with NSX. I have provided some resources here, which we won't go through now, but will be shared afterwards. And please stay for the lecture.